session, Algebra Basics. In this session, we will look at how to work with algebraic expressions. This will include combining, simplifying, and factorising terms and multiplying out brackets. So I'm going to start with a simple example of algebra in practice. If someone works for 18 hours a week and earns £14 an hour, then their gross pay is, so we just simply multiply the hours, 18 hours, by the amount they're getting per hour, 14. So the gross pay equals 18 times 14. Now, suppose we don't know how much a person earns per hour and how many hours they work in a week. We could use letters as substitutes for these values and write gross pay equals H times R, where we've used the letter H as a substitute for the value of the time they work per hour, per week in hours, and we use the letter R as a substitute for the hourly rate they're going to be paid. So this is a simple example of how we can build an algebraic statement using letters. So and we call these letters variables, as they vary, obviously, depending on what value we give them, as a substitute for unknown values. So when we write algebraic statements like this, we don't generally write the multiplication sign between the letters. So in the example here, we would just write gross pay equals HR instead of H times R. We don't do that with numbers. If I did that with the two numbers that we put here, 18 times 14, if I just wrote 1814 like that, then obviously that reads as 1814, not 18 times 14. Sometimes you'll see it written with a dot as well. So a dot sometimes is used to indicate multiplication, but more commonly there's no symbol at all. Again, we couldn't do that with when we want to multiply two numbers, when we got the numbers, because it looked like a decimal point. And we'd, in this case, we'd get 18.14. So algebra, so as I've just said, in algebra we're using letters and symbols in place of numbers. So we use the algebraic notation to present information and relationships concisely. It helps us to solve problems and reason more effectively. So a typical scenario might be that we model a situation in algebra and then do some analysis on that algebra and to get results in algebraic notation, and then we interpret the results that we've got within the algebra as to what that is telling us about the real world situation, the real world problem that we may be looking at. So when we're dealing with the algebraic symbols and numbers, letters and symbols, we're using arithmetical operations just like we do with numbers, the plus minus, multiply and division, to simplify expressions, solve equations, and rearrange formula. So these algebraic statements, what do I mean by an algebraic statement? So I'm going to divide it up into three different types. The first one is what we call an expression. So an expression doesn't have any equal sign. So if I wrote 2x plus 4, that's an algebraic expression. I can't solve it, there's no equals there. If I put an equal sign in and say maybe I make this equal to 10, this now becomes an equation, and in this particular case I would be able to solve it. In other words, I could find a particular value for the variable x. Now, some equations are considered particularly useful and we use them over and over again, so we call those formula. and they're equations where we have two or more variables. So an example you might be familiar with from your school days is the area of a circle. So the area of a circle, which I'll represent by the letter A, equals pi r squared, where r is the radius of the circle. So I've got two variables in this equation, which I'm calling a formula. We've got the A and the R. The pi, although it's a letter, it's not a variable because it's always the value 3.14. Okay, so we've got an expression, an equation, and the third type of algebraic statement is called an identity. And this is, in a way, a special type of equation where the left-hand side of the equation is always identical in value to the right-hand side. So let me give you an example of that. So if I had 2x plus 5, and then I had x plus 2 plus x plus 3, you can probably see that these two expressions are the same. They've both got two x's. They've got 2x here, we've got 2x on the right hand side, and the 2 plus 3 makes a 5. So when they're identical, we use three lines like that, and that shows that they're equal. They're an identity. So it means whatever value of x I put on the left-hand side, and I got a value. So if I put x equal to 2 into the left-hand side, I get 2 times 2 is 4, plus 5 is 9. And if I put 2 into the right-hand side, I'd get 2 plus 2 plus 2 plus 3. And that also equals 9. And it would be true for any value of x, and then it becomes an identity. So I'll just give you one more example. So say I had 2x over 10. If I double the top and the bottom, then this leaves the fraction the same. So I've doubled that and I've doubled that. So those two statements are the same. Okay. Let's have some practice at substituting values into an expression. So we've got 3a plus 2b here. When a, and it asks us to calculate the value of 3a plus 2b when a equals 2 and b equals 5. So the 3a means 3 times a. So that's 3 times 2. I'll just put it in brackets like that. And the 2b means 2 times the value of b, which is 5. So that is 3 2s are 6 plus 10 equals 16. Another way of writing it when you're substituting these values is to just use brackets and put the value inside the bracket. So where the a was, I use a pair of brackets and I just put the value 2 like that in there. And where the value b was, I can put 5 like that. So you often see people substituting values without putting the multiplication sign in, and you just put the brackets. And I'm just going to bring up a calculator, just picking it up from my other screen. So if you've got a scientific calculator like this, you can just put it in just as I said. So you can put 2 brackets. I can't remember what we had. No, it was 3. It was 3, and then we substituted the value of 2 for a. Let's try third time. Lucky 3, 3. Substitute value of 2 for a, and then for b. So then it's 2, and then we substituted the value 5 for b. So we can just write it like that, and we press equals, and that's working out 3 times 2 and 2 times 5. So especially when we've got more complex formula or substituting into a more complex expression, this can make it more compact on the screen, and you can see more clearly what you're doing once you get used to that notation, rather than putting multiplication signs in. Nothing wrong with putting multiplication signs in. It's up to you, and it might depend a bit on the situation. Okay. So just move that out of the way a bit more. So the next one, we've got 2x minus y. So when x equals minus 3 and y equals 6. So we've got 2 times x, which is 2 times minus 3, minus y, which is 6. I'll just put it in brackets to indicate that that's the number we're substituting. So we've got 2 times minus 3 is minus 6, minus 6. If you're practicing these and you've got pluses and minuses, could I suggest that you practice with trying to do it without the calculator first of all? I think so many people are used to doing these calculations with the calculator, they're not sure how to do it without the calculator. So minus 6 minus 6, think of that like an account. You're taking £6 out of an account and another £6 out of an account. So you're taking £12 down, as it were, on your account. So that is minus 12. So that's in contrast. If I multiplied minus 6 times minus 6, when I multiply two negative numbers, it makes a positive. So that will come to a positive number, and that would be plus 36. So next one, calculate the value of x squared plus 3 when x equals 10. So what does this x squared mean? So I'll put x like that in brackets plus my 3. So squared means multiply by itself. So it means 10 times 10 plus 3. So we've got 100 plus 3 equals 103. What about this one here, PQ? So we've got PQ just means P times Q. So that's minus 3 times minus 2. As I said before, 2 minuses make a plus when you multiply them together. 3 2s are 6, so it's plus 6. I'll put a plus in there just to emphasize it's a plus. And one more. Let's get rid of this. So we've got one more, x squared plus 3, and x equals minus 10 this time. So we've got minus 10 brackets squared plus 3. So that's minus 10 times minus 10 plus 3. Minus 10 times minus 3. Minus times minus is a plus. So that's 10 times 10. It's going to make plus 100. Add the 3 equals 103. I just have put this example in because people often make the mistake of when they're putting it into the calculator, they'll put minus 10 and then they'll maybe use the square button, so it's squared, and when we've added 3, you see it comes to minus 97. It's given us the wrong answer. So what the calculator's done, it's done 10 times 10 first of all, which is 100, then made it a minus. So it's minus 100 plus 3, and minus 100 plus 3 is minus 97. So when you're substituting values, it's important, especially when they're negative numbers, to put brackets around them. So there's the minus 10. If I square it, then that will square the negative as well to make it positive. And then if I add the 3, it will give me the correct answer, 103. Right, some more examples where we're substituting it, but here we're using formulae. So I've chosen a couple from different areas. So in electronics, if you're doing electrical engineering, maybe you have come across, or you will be coming across, Ohm's law. So Ohm's law says that V equals IR. So V stands for voltage, I is the current measured in amps, and R is the resistance measured in ohms. So I've got a little circuit there. So it's It's got a current of 3 amps and a resistance of 2 ohms. What is the magnitude of the voltage across the resistor? So you don't really need to know anything about the physics of this. We can just use the formula V equals IR. So we know that that means I times R. And we've been given the current, I, it's 3 amps. So I'll just write 3. And we've been given the resistance in ohms, which is 2 ohms. So that's 3 times 6. And it gives us the result, the voltage in volts. That's a little v. So I'm going to put a little v there. So it's 6 volts. So it's a very simple formula to use, just multiplying 2 and 2 together. It's a bit like the example we had right at the beginning of the session, talking about wages, number of hours times the number of hours worked. Let's look at another example. Maybe if you're doing a nursing course, you'll probably have to learn how to calculate the body mass index. And even if you're not a nurse, you might have worked this out anyway. So there's a formula for the body mass index, and it's the weight in kilograms over the height in meters squared. Height squared, you can see the little 2 there. If I was just writing it in letters, I could write W over H squared like that. So what is the BMI of someone who has a weight of 70 kilograms and a height of 165 centimeters to the nearest whole number? So you have to put the weight at the top, 70, and then we have to put the height at the bottom. Now here we have to be careful. We don't just put 165 squared. We've got our height in centimeters. So we have to look at the formula and make sure the units that it's asking us to do, in this case, it's in meters. So we've got to make sure it's in the right units. So 165 centimeters, there's 100 centimeters in a meter. So decimal place there, divide by 100, move the decimal place 2 places to the right, and we get 1.65 meters. So that's in the correct units now. So we put 1.65 squared like that. And then we work that out. So let's just bring that over here. Now, if you haven't got if you've just got an ordinary calculator or you're using your mobile phone, you're going to have to work out the bottom value first of all on its own. So it's 1.65 times 1.65. Because I'm using clicks rather than the buttons. 1.65. That's equals, and that gives me 2.7225. Then you're going to have to write that down, and then I would divide it into the answer. So I do 70. On this calculator, I can divide by the answer that I just got, and I'll get this value here. The advantage of having a scientific calculator is I can put fraction where it's got this sort of display. I can put it in as a fraction exactly like it appears in the formula, and this is very useful, especially when you've got more complex formula. So I'm going to put 1.65 times 1.65. That gives me the same value, so it's 0.2571. 0.2571. Now it does say write it to the nearest whole number, which is let's go back. I realised it should be a whole number, and I just realised that I've put 165. You probably noticed that as I did it. Let's clear that again. So it's because I'm using my mouse to enter it, which is not so easy. So it's 1.65 times 1.65. 25.71. So that's just 100 times what I had before. Get rid of that. So it's 25.71. We want it to the nearest whole number. So we're going to chop it off there. This number is 7, it's 5 or above. It's past the halfway mark. So we're going to have to round it up. So we write 26, 26, and I write BMI afterwards to indicate that's what I've worked out, the BMI. So it's 26 BMI. Okay, now at this stage, I've got another example, which I'm not going to do myself, but what I would suggest you do is pause the video at this stage, and it's going to use, and this problem is asking to find the area of a triangle, and there's this formula called the Heron's formula, and you don't need the angles inside the triangle, you just need the lengths of the 3 sides of the triangle. So we've got this piece of land, and it's 12 meters one side, 16 meters the other, and 22 meters the other side. So you might have to work out this sort of thing if you're doing a surveying course. You want to work out construction costs. You're laying that area, that piece of land with a surface. So you might have to work out how much materials you've got to use. So Heron's formula is a more complex one. That's why I've put it in here, just to see. It's almost testing your calculator skills. So on this, you have to first of all work out half the perimeter, that's the S. So you add up the 3 sides, divide by 2, and then you put that value of S into this formula here, this area, which is the square root of, and all that in the brackets there, with the brackets there. So I'll just leave that up there, just pause there, and there's 2 steps, work out S, and then work out the value of formula. My next slide, I'm going to give the solution. So I'm going to close that down. So the solution, if you've had a go, is there. So I'll just leave that up for a minute or two. So you can pause the video if you want to look at that. All right, let's go on to simplifying expressions. So we can sometimes simplify expressions by combining terms. So what do I mean by a term? So a term is either a single number or a variable, or numbers and variables which have been multiplied together. And they're separated by pluses and minuses. So it's, makes it sound more difficult than it is really. When you look at it, I'll circle each of the terms. So that's one term, there's another term. And notice that as I circle it, I'm including the sign in front of that particular item. So each of those are terms. So I've got 5 terms in that. The first one doesn't have a symbol, but it's implied it's a plus. And when you're manipulating these expressions, you can move these around. It's just like numbers. If you've got, if I've got 5 plus 6 minus 7, I can turn that around, put the minus 7 at the front, and the plus 5 and the plus 6. It's just like ordinary arithmetic. It doesn't matter which order they come in. So there's 5 terms. Let me take that away. Now, this 3 here, which is in front of some letters here, x squared, we call that the coefficient, a coefficient. So we can say that 3 is the coefficient of, and we usually say the x squared term. So 3 is the coefficient of the x squared term. And we could say that 2 is the coefficient, plus 2 is the coefficient of xy. Now we've got minus y, 1 minus y squared. So there's an implied 1 there. So we don't, when it's just 1, we don't put it in. So we can say the coefficient of y squared is minus 1. The coefficient of 2x is 2. And then when it comes to this number at the end, which doesn't have any letters, here, this -8, because it doesn't vary, it's just, there's no letters in it, the value stays the same, whatever the value of x or y. So we call this a constant term. This is the constant. So you'll hear people talking about the constant in an expression. So I just wanted to introduce those two terms, constant and coefficient. So you can sometimes simplify expressions, as I said, by adding and subtracting terms, but you can only do that if they've got the same letters in each of the terms and the powers of the corresponding letters in each of the terms are the same. So let me give some examples of that. So here we've got in this first one, 4a plus 2b one, two, 6 terms. So I'm going to arrange them so that you can see some of them got the same letters. So I'm going to arrange it so that the letters, so the two A's, the ones with A's in, are close to each other. And then the B's, we've got a 2B there and a -B there. So we've got a 2B minus B, and then we've got the two numbers. So I've just rearranged it. And then I'm allowed to add these, the 4a and the 2a. That will make 6a. 2b minus b is, okay, so let's be careful here. We've got 2b, and this is like minus 1b. So 2 minus 1 is 1. So we've got minus 1b plus 3 plus 7. So 3 plus 7 is 10. Now we don't put the 1 in front of the b, so we just got minus b plus 10. So once you get used to it, you can start to, you don't have to write all these intermediate lines. You can go straight to this line once you've got used to how to add these terms together. Let's do this one down here, 3/7 minus 4d plus c plus d plus 2e. So again, I will put the letters which are similar next to each other, 3c plus c minus 4d plus d plus 2e. So just to make it more clear, this c is like a 1c and this d is like a 1d. So we've got 3c plus 1c is 4c. Now we've got minus 4d plus 1d. Let's just do it there. So we're doing minus 4 plus 1. Think of the number line. We're not multiplying them together. This is 0. We've got minus 4 down here. If we add 1, we're going this way, plus 1. So that takes us to minus 3. So this is minus 3d plus 2e. Finally, we've got this one, 3s squared t4 plus 3s squared t to the power 4 plus 2s squared t to the power 4. So you can see they both got s and t's in, but also the powers of the s is 2, and it's 2 in both terms, and the power of the t is 4 in both terms. So they've both got the same powers. So that means we can call these like terms, just to emphasize that, what we mean by like terms. So we got 3 plus 2, we got 5 of them. So that is 5s squared t to the 4. So if some terms you cannot combine. So if we just look at these examples here, 4a plus 2b, obviously one's got a and one's got b in, so we can't add them. On the second one, we've got x and y in both of them, so that's okay. We've got the same letters, but you'll see that the value of the power of the x here is 3, and the value of the power of the x here is 2. So they're different powers of x. Even the powers of y's are the same, but because the powers of x are different, we can't add them. And a plus 6, we can't add them because one's got a letter in and one's just a constant term. There's no letter in it. All right, so now I would suggest again that you pause the video and look at these 9 problems here. Simplify the following where possible. Okay, I'll go through them quickly now. So 5d plus 3d, that's 8d. 3ab squared plus 4ab squared. They're like terms, so that's 7ab squared. 6g plus g is 7g. 4y cubed minus y cubed is 3y cubed. 3ab squared plus 5ab. Now here they've both got ab, but this is b squared. This is a b on its own. So I'll just highlight that with blue, so that just to indicate that you can't simplify that one. 5s squared t squared minus 4st squared. So they're like terms. So it's 1s squared t squared. But we don't need the 1 in front, so we just write s squared t squared. 5d minus 7t, 5 minus 7 is minus 2d. 5s squared t squared minus 4s squared w squared. One's got a w, the other one term hasn't, so you can't simplify that one. And the last one, 2a squared plus 4a squared. So these two are like terms. So that makes 6ac squared, and then we can't add the 4ac because this has got a c and not a c squared, so we have to leave it like that. Okay, let's go on to multiplying with brackets. So when we've got a single bracket like this, we multiply the bracket by what's outside the bracket. So here we've got 5 outside the bracket. So this is shorthand for 4 times 3n minus 4. And what we do is we multiply the 5 by the 3n, and then we multiply the minus 4 by the 5. So we multiply both things by the 5. So this is 5 times 3n plus 5 times, and don't forget the minus in front of the 4, 5 times the minus. So 5 times 3n is 15n. 5 times minus 4 is minus 20, or plus minus 20. Let me just show you that, so in case it confuses you. So it's like plus minus 20. So plus minus 20 is just minus 20. So it's 5n minus 20. So we do the same thing on the second one. We multiply 2n times 8n and 2n times 7. So we've got 2n times 8n plus 2n times 7. 2 times 8 is 16. N times n is n squared. So this is 16n squared. Let me just break this down a bit. This first bracket, that means 2 times n times 8 times n. Multiplication, it doesn't matter which order you do it in. So this is like 2 times 8 times n times n. And that's where we've got the 16 and the n squared. And the second one, we've got 2n times 7. If it confuses you a bit that it's that way round, and multiplication, doesn't matter which way round you do it, and that's the same as 7 times 2n, so that makes 14n. Let's do one more like this. So we've got 2 plus 3n minus 7 minus n. So visually, this, you don't do the 2 plus 3 first. You're sort of doing BODMAS really. If you've heard of BODMAS, it's doing the multiplication first. So deal with the brackets first. or the multiplication of the brackets, should I say. So I've got the 2 at the front, and then I'm going to do this multiplication, 3 times n and 3 times minus 7. So I'm going to get 3n plus 3 times minus 7 is minus 21. And then I've got the minus n at the end. So I'll just highlight here. That's the bit that I've multiplied out. Now I can simplify. I've got 3n minus n, so that's 2n. And then I've got 2 minus 21 is minus 19. Let's do it with double brackets now. So we've got 3n plus 2 times n minus 4. And the way to look at this is think that we're going to break this down into 2 separate multiplications like the one we had before. So we first of all look at the 3n and we multiply that by the bracket. So we've got 3n, n minus 4, and then we've got the plus 2. So then we do the plus 2 of the n minus 4. And then that looks like the brackets we've just done in the previous section. So we do 3n times n, 3n times minus 4, 2n times n, and 2 times minus 4. So that gives us 3n squared minus 12n plus 2n minus 8. And then we simplify if we can, and we can in this case. We've got minus 12n here and plus 2n. So they're like terms. So we've got 3n squared minus 12n plus 2n is minus 10n minus 8. And that's as far as we go in terms of simplifying. So we've multiplied these 2 terms here, these 2 brackets. Just some extra terminology. This expression here, 3n plus 2, it's got 2 terms. So we call that a binomial, bi as in 2. So we're multiplying 2 binomials together. And what we're getting is this expression here, and this has got an n squared. So anything, so this is a kind of polynomial. We've got squared term and a linear term, n term. So just by the by, this is called a quadratic. Now, people often use the acronym FOIL to remember how the order that you do, well, not the order, but the different multiplications you do when you're multiplying these 2 binomials. So I'll just write FOIL down here, and I'll just quickly show you what we mean by that. So we've got 3n plus 2, let's write it out again, n minus 4. So we've got first, outer, inner, and last. So the first, once you do it, means you take the first from each bracket. So it's 3n times n. And then you take the outer, so that's the 3n and the minus 4. That's the outside terms of both brackets. Then you do the inner brackets, so it's the 2 times n. And then you do the last ones from both brackets. So you're doing that sort of pattern. And in fact, that's the order I've done it, the way I did it first of all. So you'll get those 4 terms. So each time when you multiply 2 binomials like this, you're going to get 4 terms, and then you may be able to, you might not, but you might be able to simplify it. So it goes to fewer terms. Let's do one more like this. Well, we've got 2 mums. We've got p plus 5 squared. What does that mean? It means p plus 5 times p plus 5. So if we use FOIL, we're going to do p times p times 5, 5 times p, and 5 times 5. So we get p times p is p squared, p times 5 is 5p. So notice, so we did p times 5. We could have written it as p5, but usually we don't write it like that. We put the number before any letters. So it's 5p. Again, it's multiplication. It doesn't matter that we just turn it around like that. It gives you the same value. So we got 5p. That was the outer, and now the inner is 5 times p. So it's 5p. And 5 times 5 is 25. So we got p squared plus, and these two terms in the middle we can combine. They're the like terms, 10p plus 25. And the last example, multiplying out of brackets, is this one here, and the difference with this one is that the second bracket has more than 2 terms. It has 3 terms. Now, as you've got more terms in the brackets, sometimes it's useful to do the multiplication in the way of a table. So I write down a table, like a multiplication table like this. I'm going to multiply, and I put the 2 terms. So I'll first of all put this one, the 10a and the 2b. So we've got 10a, making sure you've got any signs. So they're both positive, so I just write 10a, 2b. There's no negatives. Remember to put negatives there if they're negatives. And then I put the other terms along the top. So I've got 3a, create some space between them, 3a, 2b, and c. And then I multiply them out like I would a multiplication table. So 10a times 3a is 30a squared. 10a times 2b is 20ab. 10a times c is 10ac. 2b times 3a is 6ba. So this is another convention. I will put the letters in alphabetical order, because I could put 6ba or 6ab. So I'll put them in alphabetical order. 6ab, then 2b times 2b is 4b squared. 2b times c is 2bc. Then I add them all up. And you'll notice before I add them up, I can see that this term and this term are like terms, so I can combine those. So just to save time, I'll do it before I write them all out. So I've got 30a squared. Then if I add the 2 like terms, that's 20 plus 6, that's 26ab, plus 10ac, plus 4b squared, it doesn't matter which order you put these in, plus 2bc. So you can see, having a table, it makes sure that you've done all the multiplications. We've got 6 terms in the table, and in this case we can reduce it down to 5 because 2 of them are like terms. Okay, the final thing I want to do in this session is factorising an expression. So this is the reverse operation of what we've just been doing. So it's a bit like with numbers. So say you were multiplying 2 numbers, 2 times 3 equals 6. That's what we've been doing, multiplying 2 things. If I want to go the other way, if I start with a 6, I can factorise it into 2 numbers, in this case 2 times 3. So it's like we're looking at the second example now. So let's factorise 28a plus 12. So you look for something common to both for the 28 and the 12. And I can see that 4, you look for the highest number that will go into it. You're looking basically at the highest common factor. So 4 will go into 28 and 4 will go into 12. That's the highest number. And that's the thing I take outside the brackets. And inside the brackets, first of all, write exactly what you had before, 28a plus 12, and then divide it by the thing that you've taken, each of the terms in the bracket by the thing that you've taken out. We've taken out 4, so divide them by 4, and we get 4 brackets. 4, we cancel this down, 4 into 28 goes 7, so we've got 7a, and 4 into 12 go 3, so we've got 4, 7a plus 3. And in your mind, you might want to just check that you've done the right thing. So just think, if I was multiplying the other way, I'd do 4 times 7a, which is my 28a. And if I did 4 times 3, I'd get 12. So that just reassures me that I've factorised correctly. We just emphasise how we're factorising. I'll put the 4 in brackets. So we're doing the 4 times the 7a plus 3. So these are the two factors. So we split it up into those two factors, and if you like, there's a multiplication sign. So that's the equivalent of the two factors. That's why it's called factorising. One more example here. We've got 24n squared p minus 18p squared. So first of all, look at the numbers 24 and 18 like we did before. What's the highest factor which will go to 24 and 18? It will be 6. Now look at the letters. I'm going to split it up. We've got n squared p here. So we've got an n, and a p. That's n squared p. And here we've got p squared, a p and a p. What's common to those two? We've got one p common to the both of them. There's not two p's on this left-hand one, so we can't do more than one p. There's no n's common. So we've got a p, which is common. So we take 6p out of the brackets. And then we write down what we had before in the brackets, 24n squared minus 18p squared. Divide both sides by the thing that we took out, which is 6p. And then do any cancelling that we can. So we can cancel that p with that p. 6 is into 24 will go 4. So we're left with 4n squared. And then 6 is into 18 go 3. So we've got 3 minus 3 p squared over p. Let me just bring that out here. So that means p times p over p. I can cancel that p with that p. Well, basically, I'm dividing by p top and bottom, making 1s. So that leaves me with just a p on top, p over 1 or p. So this is p here. So I've got 6p brackets 4n squared minus 3p. And again, multiply them out, maybe in your head, just to check that it will go back to the original expression. So that brings me to the end of the material I'm going to cover in this session. If you want further practice, there are some links here on this final page. So I've basically gone through the same order that they do on BBC Bitesize. So you'll see through the different pages, the sections that I've gone through, I've put a link to the section that's relevant, and you can get some more practice on each of the bits I've done. You might want to look at Wolfram Alpha, which allows you to check your solutions. So that's allows you to put algebraic expressions into that website. They have an input box, and it will do calculations from algebra, unlike your average calculator. And another place to look is the resources that we have on our Moodle, on our library site. So if I click that site there, I'll bring the browser over onto the screen. So this has gone to our maths site, and we've got resources, and you'll see there's a section on algebra there, and you might want to have a look at some of the worksheets there and videos, etc. in that section, or anything else on that site. To get to our site, if you don't want to, if you just want to get to our maths and stats site on the library, you don't have to go through a link. You can just Google maths. I'm just typing it in here, stats. You see that I've done it before, LSBU. If I press return, it'll come to the top link. So I click there, and it gives you the top page of our maths and stats information, and maths resources was the one that I was just looking at there. The other place that would be helpful for you to know is the Study Ready homepage. So this is library.lsbu.ac.uk, if you don't know it. And if you scroll down, there's a section that says Maths Programme, and you will see a number of the lessons. So we've just done Algebra Basics. The recordings for this session will be here as well. If I click Algebra Basics, that's a PDF of a session, this session that I did with some students. If you scroll right, and it's got the links there, so you can just click on the links in the PDF, scroll right to the bottom, it's got those links for further study right at the end. So that's somewhere else you can look afterwards if you want to follow up on what we've done here. So that brings me to the end of this session, and thank you for listening.